Hello, and welcome back to the Rice Robotics Robo-Tutorial. So this is our third video, and this one we'll be designing this base plate, which sits on top of this base hub and rotates in this direction. It's rotated by this motor. Up top, it has some mounting positions for the servos. It has some support positions for this first link. And then also, if we hide this base hub, we can see that at the base of the base plate, we have a gear, and that engages with the drive gear that we've just created. And that's how this motor is allowed to manage the rotation of the base plate. So we'll be doing the CAD for the base plate here. This is what it looks like. And it'll start by creating this larger gear. Let's go back to our Onshape document. We need to create another new part studio. Just as before. Name this part studio base plate. So we'll start by creating another spur gear, just like in our previous video. We're going to use the custom feature tool that we added in the previous step. In this case, it's very important that these two gears have the same module and the same pressure angle, because that's going to make them compatible with one another. So remember from earlier, we had a module of 2.5 millimeters, and we had a pressure angle of 30 degrees. The depth doesn't matter too much, but in this case, we're going to use a depth of 7.5 millimeters. And we want to make sure this gear has 32 teeth. And now 32, that means that this gear has 4 times as many teeth as the drive gear, which means this gear, whenever the drive gear rotates, this larger gear will rotate at 1/4 the speed, but that also means it will deliver 4 times the torque that it gets from the drive gear, which is good to know. That means that basically we're increasing the torque of the motor that's being delivered by the drive gear, but decreasing its speed by the same factor. So good stuff to know. Make sure that this root fillet is still 1/3. It probably will be. Click the green check mark. And now this gear is added. So now we're going to add a plate on top of this gear, or I guess to the right of this gear, where all of our other components will sit. So create a new sketch. Click the back face of this gear. Right click and reorient the view. So you've got to be careful. Throughout this tutorial, I'm often going to tell you to align things horizontally and vertically. But in this case, you can see the z-axis is aligned horizontally, and the x-axis is aligned vertically, which is going to make our vertical and horizontal relations really weird. So instead, just make sure that that x-axis, or whatever your horizontal axis is always actually horizontal, and that's going to avoid a lot of confusion for both of us. So that's what I recommend you do. And so this sketch is going to be another circle centered at the origin. As always, pretty larger than the gear. And then we're going to add a dimension to specify its diameter. It is going to have a diameter of 140 millimeters. That's the exact same diameter as the largest circular edge of our base, if you remember. If you don't, that's okay. It is, trust me. And so that's the size of that circle. The sketch is fully defined, and so now we're going to extrude that sketch and create the plate that sits on top of this gear. So yes, we're going to extrude this plate 10 millimeters. Be going away, adding material, and create a plate on top of this gear. Click the green check mark to finalize the sketch. Oh, it is important. We need to go back in. You can right click and you can edit feature at any time. I don't want to be adding material because the gear and this top plate are going to be different bodies. So instead of adding, I'm going to make sure that we're actually creating a new body with this extrusion. So select new, click the green check mark, and now they're different colors, which indicates that they are actually different bodies, which is what we want because we'll be printing these two parts separately. So now I'll make sure to name your extrusion. And now we're going to create another sketch on top of this plate. Okay, now we're going to draw several rectangles. So first, we're going to draw a center point rectangle. We're going to draw it anywhere, make sure that it's not trying to align it with the origin in any way just yet. just draw it out in space. And the dimensions of this rectangle, we're going to give it a height of 23 millimeters and a width of 7 millimeters. By the way, what these are going to form is this is going to form the support points that I showed you earlier for the first link of our robot arm. So the rectangle size is fully defined, but its position still needs to be defined. To do that, we are going to actually horizontally align the center point of this rectangle with the origin, which you can either do just by creating a horizontal relation just like before, or you can just drag it into place and it will automatically try and create that relation, which works for our purposes. Now we need to create another center point rectangle. It's actually also going to have its center point aligned with the origin, but it's going to be on the other side. And we want this rectangle to be exactly the same size as this previous rectangle. So just like we did with whenever we were designing the base hub, we're going to use equal relations to make these rectangles the same size. So just select the corresponding edges, and then this rectangle will be made the exact same size as the other rectangle. And our sketch is almost complete. First, we need to define the distance between these two rectangles, and we want it to be 10 millimeters. So we're going to add a dimension between their inside edges. So 10 millimeters. Then still not quite fully defined. We want these to actually be centered on the plate. So there's several ways to do that. The way I'm going to do it is I'm just going to define a 5 millimeter dimension between the origin and this center point. Let me drag this over here. Okay. By the way, you can reposition dimensions at any time if they're like overlapping each other. Just click the dimension and drag it, and you can move it to a more convenient position that's easier to see. So our last dimension is going to be a 5 millimeter dimension between the origin and between this center point. Make sure it's 5 millimeters. Oh, I've made a mistake. So this dimension doesn't need to be between the origin and this center point. If we want these rectangles to be centered on this plate, it actually needs to be between this edge and this center point. So to fix this, I'm going to select this dimension, click delete, then I'm going to remake that dimension and drag these around. Click the origin, and click this edge of the rectangle. And now I'm going to define 5 millimeters, and now it's fully defined correctly. So our support points are created, at least the sketches for them are. So we're going to extrude these up. By the way, if you're still in a sketch and you click extrude, it will just automatically extrude that sketch up. So automatically is often a convenient way to save some time if you just know that you're going to immediately be extruding a sketch. So I may be doing that a lot going forward. Just keep that in mind. So we're going to extrude them up away from the plate with the depth of 22 millimeters. Type that in. And now this feature is complete. Make sure to name feature. Okay, so now we're going to add some cutouts to refine the geometry of these support points. So to do that, we're going to create a sketch on one of the outside faces of these rectangles. Make sure that you're looking at it from this direction. So we're going to right click to reorient our view. Now first, we're going to add a circular cutout, which is going to go through the top half of these support points. So it's going to be a center point, and its center point is going to be located at the midpoint of this top edge. So just follow that edge until you see a box appear. That's when you know you found the midpoint. And this circle is going to have a diameter of 15 millimeters. Now that one is fully defined, but we're not quite ready to extrude. We first need to add some triangular cutouts here, and that's actually to make up for a poor design decision I made at an earlier stage in this process. So I'll show you that whenever it comes up here in a second. Also, if you're more advanced and you're wanting to fix this problem, there are several ways to address it. I'm just being lazy, so keep that in mind. But we're going to draw a triangular cutout that will fix this issue. So we're going to form a triangle on the right side of this rectangular extrusion. It's going to start in the top right corner. Make the second line, or the second endpoint coincident somewhere along this bottom edge. Make sure it's not the midpoint or anything like that, just somewhere like that. And then it comes over here. You're still drawing a line, by the way. So the second line is going to end bottom left corner. And then it's just going to end all the way back up at the top right. And now we've created this triangle. And to fully define it, we need to define the length of this edge. We're add a dimension, and it is going to be 5 millimeters wide. So we've created the triangle. That's exactly how we want it. Now we're going to mirror it across this line, so that we have one on the other side of the shape as well. Click the mirror tool from the toolbar. Select this to be the mirror line. Drag to select the triangle. Oh, I hope I didn't just mirror that circle. I think I did. Just gonna select the edges individually then. Click mirror again, click the line. Just gonna mirror them one at a time. Great. Okay, now the sketch is complete. We're ready to add this cutout. So click the green check mark, or actually, I'll just go straight to extrude. Now we want to be removing material. And we want to just cut all the way through these support points, through both of them actually. So just use a through all ends type. That cuts through both of them. And now we have a bit of a leaner support that also has space for link 1 to sit. So you'll see what that actually looks like once we create link 1, but we're done with the support points for now. Make sure to name your feature as always. Okay, and now we need one more piece, which is going to look a little random right now. It's a very simple piece that we're adding. Create a new sketch on this top plane. Right click to reorient the sketch. Okay, and we're going to create a center point rectangle. It's going to be horizontally aligned with the origin. And this dimension, it's going to be 4.8 millimeters wide, and then 11 millimeters tall. So 4.8 millimeters here, 11 millimeters here. And then we want this edge to be coincident or to be like on the same line as this edge here. So go to the relations menu, select coincident, make this line, and this edge coincident. I'll make them sit on the same line, and now this feature, this sketch is complete. Or click the green check mark. I'm going to extrude this sketch with a depth of 11 millimeters. Click the green check mark. And now I've created this little block. It looks a little bit random, but what it's used for is it'll be used to keep our pulley in alignment once we connect it to the rest of the arm. So it's gonna be a little while before I can like show you what that means. But just trust me, it is necessary. Okay, so we've added the support points. Now we need to add those servo holders that we saw before. So we're going to create a new sketch on the top face of this base plate. Right click to reorient the view. Okay, so we're going to draw a corner rectangle. Make sure to draw a corner rectangle, not a center point rectangle. Oftentimes they'll both work, but in this case, we're just going to opt for a corner rectangle. It is going to have a height of 12.2 millimeters and a width of 15.7 millimeters. Okay. And now we're going to see it may have been more convenient to use the midpoint rectangle because it automatically gives you that point in the middle that you can use to reference other geometry. And we do want to align the midpoint of this edge with the origin. But since we don't have that midpoint, we're going to have to add our own point. We're just going to add a point at the midpoint of this edge. So just drag along it until you see the box appear. Click to make the point. Now we're going to align these two horizontally. Make sure that your x-axis is pointing in the right direction so we don't get confused. In this case, it is, so we're all good. Click horizontal in the relations menu. Select the point that we've just created and the origin, and now they're aligned horizontally. And now we're going to lock this rectangle into place by specifying its horizontal position. So if I'm following the instructions, it should actually sit over here. Ooh, no, it shouldn't. It should sit here. So it's a little confusing. Our view is thrown off a little bit right now. We're going to rotate all the way around. So this is on the right side. Don't worry too much about that. Basically, we just need to add a dimension between the left edge of this rectangle and the right edge of the support point. And that dimension is going to be 25.7 millimeters. And that's just the proper distance so that this pulley and the servo and everything is spaced properly once we put everything in the full assembly. So this rectangle is fully defined, but now we're going to use a new tool called the offset tool. The offset tool takes existing geometry, but then offsets it by a set distance. So find the offset tool in the toolbar, it's right here. And then we're going to select all of the edges we want to offset. So we're going to offset all edges of this rectangle except for this edge. So offset the top, right, and the bottom. And before confirming, we want to set this distance, and we want the offset distance to be 3 millimeters. So set 3 millimeters. And now confirm with the left click of the mouse. Click enter one more time to confirm the offset. And now it's almost fully defined, but these points are not fully defined because they aren't connected here yet, which is what I want to do. So we're going to need to add 2 small lines, one here, then one here to like fully close the shape. And then the last thing to do to fully define it is zoom in a little bit and make sure both of these lines are constrained to be vertical, because right now we can drag it around and it can take all sorts of angles. We want these 2 blue lines to have to be vertical. So select the vertical relation from the menu, and then select both lines. And now the shape is fully defined. Let's see, I'm a little worried I've messed something up here. Let's see. We're going to go back a little bit. Maybe not. Maybe it's all good. I'm just going to draw these lines again. If you draw here and here. Okay, never mind. I thought what was happening is I was continuing to draw, and so I drew another line in here. And if you have like a geometry that's not accounted for, it can often make the modeling process very confusing. So you want to avoid that if you can. In this case, it wasn't an issue. So apply this relation again. And now the servo holder, the first servo holder, is fully defined. However, we want a servo holder on this side, and we also want another servo holder on this side. So we're going to use copy and paste, drag to select all of these sketch entities, right click, select copy sketch entities, click away there, and then right click somewhere on the left side of the base plate and hit paste sketch entities. So once it pastes, it has all the sketch entities here, but it also gives you the option to move it vertically by a specified amount, horizontally, and then it also allows you to rotate it. And that's what we're concerned with, because if the pulley mount opens this way, the pulley will be facing this way. But we want the pulley on this side to be also facing these support points. So grab the rotational option, rotate it, make sure that says 180 degrees, type it in if you need to. Left click to confirm. And now it's still underdefined because we still need to specify its position. So first we're going to align this midpoint, just like before, horizontally with the origin. So now it's constrained there, but it can still slide in this direction, so we need to constrain that distance. And then we're going to add a dimension to fully define this second servo holder. It'll be between the rightmost edge of this servo holder and then the left edge of this support. So make sure you're not getting this edge of this rectangular piece we added to support the pulley. Make sure you're getting the left edge of this support here. That distance is going to be 35 millimeters. Okay, great. Now this sketch is fully defined, and now we're going to take this geometry and actually make two new extruded features. So click the green check mark. Okay, we're going to start by extruding the inner rectangles. This will form the platforms where the servos will sit. So select extrude, and instead of selecting the entire sketch, we don't want to extrude all of it quite yet. So first, just extrude these inner rectangles. It is going to be a blind extrusion, and we're going to extrude them with a depth of only 5.6 millimeters. So confirm that, click the green check mark, and now we're going to add another extrude feature from the same sketch. So make sure, hover over that sketch in the feature tree and unhide it so you can still view it here. Now we're going to create another extrude feature. We're going to select those that other geometry that we haven't extruded yet. This is going to create a frame, like a set of walls that will hold the servo in place. So we're going to extrude that, and that's going to have a depth of 15 millimeters. Adding material. And now the servo mounts are pretty much complete. Now we have a spot where we can sit the servo, and it won't move around all over the place. It's pretty much constrained to sit exactly where we want it, which is great. We name these features. Great. Okay. So now to actually fully position those servos, we're also going to need a hole in each of these servo mounts so that we can screw in a bolt that'll like fix that servo in place. And this is where my questionable design decision came in, and you'll see it in just a second. So we're gonna have to add two features, one hole to each of these servo mounts. So create a new sketch. It's gonna be on the face of this servo holder. Reorient the view. And you can't, it's difficult to see what you're doing here. We'll rotate to see in a second, but it's pretty simple. We're going to draw a center point circle. It's going to be centered. It's going to be vertically aligned with the origin. In this case, you can see it's a little confusing because it's using Z as the vertical direction and Y as the horizontal direction. So it says we're actually making a horizontal, but it doesn't really matter. As long as it's aligning with the origin in the correct way, we know that's what we want. Now this circle will have a diameter of 2.44 millimeters. And then we need to properly position it on the servo holder. And we're going to add a 2.95 millimeter dimension between the center of this circle and the top of the base plate. So we want center of the circle and this top of this base plate, that vertical distance should be 2.95 millimeters. And that will properly position our hole. It's fully defined. So now we're going to extrude this hole for the circle. You can see it is on the proper surface. We want to remove material, cutting into the servo mount with a depth of 5 millimeters. Okay, click the green check mark. Now here's my poor design decision, which is that it's whenever we actually print these parts and try and screw this in, it's going to be very difficult because you can't come in straight because you have support points here. So getting a screwdriver in from this direction is difficult. You can come in from the top, which works fairly well. It works okay, but it is difficult. Or you can try to come in from the side, which is much easier if you add this inclined cut. So that's why I added that cut. There are definitely ways to avoid this issue in a much better way. So if you want to try and implement that, go for it. Definitely should explore your options there. But for this case, we're just going to live with the error of my ways. And so we're going to create another one on this other servo mount. Create a new sketch on the same face or same type of face as before, just on the servo mount. Reorient the view, and this is going to be exactly the same. Center point circle aligned with the origin. It's going to have a diameter of 2.44 millimeters. And it's going to have a dimension that says it's 2.95 millimeters vertical from the top of the base plate. We're going to extrude this one as well. Make sure that sketch is actually on the correct face, which it is. We're going to remove material with a depth of 5 millimeters. Click the green check mark to confirm the feature. Make sure to name these. Also, you don't have to name these exactly like I'm naming them. Just name them so that both you understand what they are and someone else that comes in could like feasibly understand what purpose they have in your overall design. So the servo mounts are complete, and now we need to add a few more features just to add cutouts that will both connect the gear to the base plate, or we can put a bolt that will connect them together. And we also need to add some holes so that wires can get from the top of the base plate down into the base hub. So we'll start by creating a sketch on the bottom face of the gear. So create a new sketch. It's going to be on this bottom face. Right click to reorient the view. Now it's going to be a circle. It's going to be centered at the origin, and it's going to be 20 millimeters in diameter. So we've done this a bunch of times already. Use a dimension, specify the diameter to be 20 millimeters. Now the circle is fully defined. We're going to extrude it, and we want this circle to remove material all the way through the gear, but we don't want it to mess with this base plate. So there's actually two different ways you can go about doing this. First, make sure that we are removing material. So either you can use the up to face int type, like we've done before, which would just be used to extrude this circle and remove material up to the bottom of the base plate, or you can actually use a through all condition. And the reason you can do that is because the gear, the base plate, are different bodies. And so you can say that this cut will basically only apply to this gear. And the way you do that is by specifying the merge scope. So we're going to X out, we're going to eliminate that. Going to extrude, it's going to be a through all int type. So it's asking for merge scope. It says there's an error because we haven't told it to merge with anything. So we're going to say merge with all. And if you merge with all, you can see it cuts all the way through both the gear and our base plate, which is not what we want. So instead, we're going to merge not with all bodies, but just with the gear. So down here, we have our bodies listed. We just want to cut through the spur gear. And you can see it is still a through all cut, but it's not doing anything to our base plate, which is great. That's what we want. So confirm the feature. And now we'll add another cutout. It's going to be on the top of our base plate. This is how wires are going to get down into the base hub. We're going to draw a corner rectangle. Its first corner will be at the, I see. Okay, so instead, we're going to create a center point rectangle. It's going to be centered at the origin here. So mark the center point there, and then just kind of drag it out to any point. We'll constrain it more in a second. Now I believe, okay, we'll want to make this edge coincident with this edge, and we'll make this edge coincident with this edge. Okay, so select coincident, click the top edge here, the top edge of the support, it locks it in that direction. Do the same with these two edges. And now we've filled in the space between these supports with a rectangle, and that will be used for our next cutout. The sketch is fully defined, so click extrude. We're going to be removing material, and we'll do exactly what we've just done with the gear. Make sure the merge scope is only part 2, which I should name, but in this case is just the base plate. Give it a through all in condition. Click the green check mark. And now you can see we have this rectangular hole, and it goes straight into our circular hole in our gear. So that's great. That allows a path for our wires to move through so that they can access the electronics. Okay, we're almost done, I promise. I believe we have one more feature, and it will be the holes that will allow us to attach the gear to the base plate. So it's going to be a sketch on the top face of the base plate. Reorient the view normal to the sketch plane. Okay, we're going to need two 5mm circles to mount the two bodies together. So we're going to draw a center point circle. Its center is going to be vertically aligned with the origin. Okay. Use a dimension to make the circle's diameter 5mm. Now we want to define the vertical distance between the circle's center and the origin to be 23mm. Great. So now we want another circle on the opposite side of the gear so we can connect them very well together. So use the mirror tool. We're going to mirror this circle about this line. So select the mirror line, one that divides the gear in this direction. Select the circle, it'll mirror it automatically. And then now our sketch is complete. So we're actually going to extrude both of these circles all the way through both parts because they'll be used to connect the gear to the base plate. So they should be like in the same positions. So the gear is complete. Go to extrude. You're going to extrude it through all parts. So it says right now it's only merging with the base plate, but we actually want it to merge with all. So check that option. Want to remove material, and we're going to use another through all end type because we just want to cut through all of the materials. Let's see. What's that about my choices? Oh, I see. Okay. So we just need to make sure we reverse the direction and it'll cut down, remove material from both the gear and the base plate. Click the green check mark to confirm. And now this base plate is complete. We have spots for the servos to sit. We have a support point for link 1, support point for the pulley, some holes so the wires can go from the top of the base plate to the base hub, and we have a gear that allows this base hub to be driven by the motor. So great job. That was a complex one. Took a lot of different features. Make sure to name these features so everything is clear. Okay, and now this part is complete, so we'll move on to the next one.